Welcome back. What we have seen so far is the fact that there seem to be levels of temperatures which can be arranged in a particular order. Actually, extending what we did a few minutes ago, we notice that it can be extended to the following fact. Suppose we have a number of systems at different temperatures, and let us represent those temperatures by thermal energy reservoirs just for convenience. I am showing 5 of them here. Let us call them T1, T2, T3, T4, T5, and let us arrange them in such a way that if I try to work a 2T heat engine between T1 and T2, it will work in this fashion. It will absorb heat from Q1, it will reject heat Q2 to the reservoir at T2 and produce work, say W12. Then if I try running an engine between T2 and T3, it will absorb heat from T2, reject heat to T3 and produce some work. In a similar fashion, we can have 2 more engines, one between T3 and T4 and one between T4 and T5. Now, extending our derivations, we can show that suppose I try to run a heat engine between any 2 of these, not adjacent ones we know, we have already shown. Let us say we decide to have a heat engine running between T1 and T3. Then we can show, and we have already shown this, that this engine will work between T1 and T3 in such a way that it will absorb heat from T1 and reject heat to T3 and produce a positive amount of work. And you select, for example, another example could be you select that one reservoir is T2, another reservoir is say T5, and we try to run an engine between these two, and we will find that it will absorb heat from the reservoir at T2 and reject heat to the reservoir at T5 and produce some work output W. Okay. So that means what we have been able to deduce is that there is a hierarchy of temperatures. In this particular sketch, the hierarchy of temperatures say, for example, left to right in this particular figure. And what is the special thing about this hierarchy? If you run an engine between any 2, say T1 and T4, then you are sure that the engine will absorb heat from the reservoir which happens to be at the left of this and reject heat to the reservoir which happens towards the right side of this. Now, this hierarchy gives us an idea of what we should call the higher temperature versus lower temperature. And the way we have laid this out, the left side of this figure pertains to higher temperature and the right side of this figure pertains to lower temperature. And this we say because we have a traditional idea of what is higher and lower temperatures, and this idea has already been formalized in temperature scales like the Celsius scale, the Fahrenheit scale, and even the ideal gas Kelvin scale. Thank you.